Dear student, today we are going to perform thermogravimetric analysis in our TGA instrument. The instrument is from NETS and we'll perform a sample there. The sample is calcium oxalate. We'll first start with the introduction of thermogravimetry and then we'll perform real experiment. In general, gravimetric analysis means measurement of mass. In analytical chemistry, gravimetric analysis is used to find the mass of precipitate or volatile matter. From this information of mass, we can quantify a component in an unknown sample. Likewise, in thermogravimetric analysis, a sample is heated in a controlled thermal environment and its mass is monitored. So in TGA experiment, we will get a curve of mass versus temperature or time. So why the mass changes occur in a sample? The mass changes occur in a sample due to thermal degradation or any other physical phenomena like adsorption, desorption, or any reaction. TGA can be applied in finding thermal stability, oxidative stability in a material. It can be also used to measure the moisture and volatile content in a material. TGA can also be used to find the kinetic parameters involved in decomposition kinetics of a biomass, like in a pyrolysis study. So coming to the instrumentation, the major part of the TGA instrument are furnace, a sample holder. The sample holder contains a pan where we will put our sample. It is also known as a crucible. It is made up of alumina and it can withstand a temperature of 1600 degrees centigrade. In order to maintain a atmosphere within the TGA instrument, we can use carrier gases. And depending on the type of our requirement, we can choose the carrier gas. If you want to do it in a reactive environment, then you will use oxygen or carbon monoxide gas. Or if you want to do it in an inert environment, you will use nitrogen or argon gas. The another component of the instrument is the thermocouple that detect the temperature at the sample. And the main part of the instrument is the microbalance, and this is the heart of the instrument. So how the microbalance works in a TGA? Microbalance senses the vertical displacement of a sample due to mass change by an optical system. The optical system consists of a light source, a flag, a light tube, and a photodiode. The weight change in the sample causes the flag to move. This movement will interfere the light falling from the source to the detector or the photodiode, and there will be a generation of current. The generation of current occurs due to the change in the intensity of light falling on the photodiode. The current that is generated is proportional to the change in the mass. In the application of a typical TGA experiment, we will use calcium oxalate monohydrate as our sample and heat it to 900 degrees centigrade. During its heating, we will observe 3 stages of mass loss in calcium oxalate. In the first stage, the calcium oxalate monohydrate will lose its moisture content, and this will occur at a temperature of 100 degrees centigrade, and this is represented here. And the second stage, calcium oxalate will degrade to calcium carbonate and carbon monoxide will be released. This is represented here. And at the third stage, calcium carbonate will decompose to calcium oxide and it will release carbon dioxide. So there will be a change in the mass due to the loss of carbon dioxide in the sample, and this is represented by this step. So let's start with the real experiment. This is TGA Thermogravimetric Analysis. This is one kind of a thermal analysis equipment. In our department we have a TGA from MET, and this is the model number TG209F1. Okay, we'll start experiment now. First we have to open the gas. For our analysis we are using nitrogen gas. The pressure here should be maintained as 0.5 bar. Then we'll start the sealer. The sealer is used here to pull the furnace at the back side of the instrument. So start it. Okay. Then we start the computer. Click here. This folder will open, and then we will go to TG this icon. So this will start the instrument. So we have to wait for some time. Yeah. Instrument is being installed. Now it is got connected with the software to the instrument. Okay. First we will set the gas flow rate, and we will set 40 ml in pass gas and 20 ml for protective gas, and then we'll click OK. Then we'll go to file and create a new file. Then we'll go to header and select sample. In calibration curve we will select one curve, and then we don't have to do anything in change gases since it is nitrogen and we want to do our experiment in nitrogen. So then we'll go to temperature program and set the initial temperature at 30 degrees centigrade. And end temperature at 1000 degrees centigrade and heating rate at 10 degrees centigrade, and then we'll edit it, and then we'll go to weigh. First we have to take the empty crucible and then tear it, and then we will take the actual sample in the crucible and then again weigh it and store the final weight. To open the instrument, you have to put this in this simultaneously, and this lid will come up. This is a crucible. This is made up of aluminum material. It can go up to a temperature of 1600 degrees centigrade. So here we will put the sample for our experiment. This is actually the furnace of the instrument. This is the sample holder. Here there is a thermocouple over here that will measure the temperature of this crucible and the sample. Okay, we will store the weight and click OK, and then we will go to the header again and put the sample name in the identity field. We'll put the sample name as calcium oxalate, and go to last item and we'll create a folder name as CL514 and open it, and we'll put the sample file name as test and save it, and we'll click measure. Then we'll tear it. TG signal is now become 0, and then we will start the experiment. So our experiment has started. Okay, this is after run of 20 minutes. We have achieved our first stage decomposition in calcium oxalate, and this is after the run of 40 minutes. Now our second stage is starting. Finally, our experiment completed. So we'll click on the potash analysis and we'll open our file. CL5.4, it is there, and we open it, and we'll click evaluation and we'll click on the first derivative, and here the first derivative we have got. To export the data, we'll click on the export and it export it. We'll export it in the same folder and put the name as it is. So in the potash folder, in data folder, we can find our converted data. Here we can click it and we can see there the data is saved in an Excel format.